on managing site-specific soils for landscaping success and sustainability. I am April Thompson, the Senior Director for Bloom, and this is a series that we've done over the past year with Ron Alexander, whom I'm going to introduce in a minute, for landscape architects for an ASLA CEU. We thought, let's open this up to the wider mailing list because we know there are a lot of people interested in this topic. So it's great to see all the interest, and we're going to be in good hands with Ron on this presentation. A little background on Ron. He's got over 40 years experience in composting and organics recycling, having completed over 500 related consulting projects, presented over 400 papers and presentations, worked with over 200 composting and organics recycling facilities throughout North America and worldwide. He's won a number of awards, including recently a Lifetime Achievement Award. And he's worked extensively with Bloom on um, our product research, among other things. So without further ado, I will turn it over to you, Ron.
Okay, thanks, April. I appreciate that. Thank you all for being here today. I'm gonna go off screen here. It's always fun to talk about soil management. Again, that makes me a little bit warped, but it is an increasingly more and more important topic, not only for keeping landscapes alive, but for managing kind of the environment around us with changing weather patterns and things like that. So here are some of the things we're going to talk about today, but we'll get right into it. The presentation will be provided to you after we're all done, and April will talk to you about if you're interested in landscape architecture training CEUs, you'll be able to get that. So I'm assuming everybody here on the call is from the Mid-Atlantic area. It's obviously anywhere you are in the U.S. or the world, soil conditions, weather patterns change based on where you're located. In the area of DC, Virginia, in this area, it's very unique in that we have low-lying areas that are subject to water. The soils sometimes closer to the water are coarser and sandier, but as you move away from the water, they're more finer textured. And certainly in most of the Mid-Atlantic states, aside from the little patches of sandy soils, we have really pretty dense silt clay-based soils, generally low in organic matter, which need improvement before landscaping. Now we're living at a time now where we not only are interested in creating beautiful landscapes, but also more sustainable landscapes, ones that work a little bit better with nature. And I would argue it just really to create landscapes that have more than just an aesthetic basis. They also have a purpose. They do something. And this leads really, really well into a lot of momentum in the area of soil health and improving soils for a number of reasons. And some of the biggest drivers for getting more deeply into soil health is we're plagued with soil loss and the reduction of soil organic matter in our country. We're not great in soil maintenance practices, soil protection practices. So we're actually seeing more regulations being developed for that reason. Poor soil characteristics, especially dense soil, and changing water power patterns, rain patterns, where we have heavier rainstorms, means we have more stormwater problems and which leads to the rising cost of infrastructure to manage water, right? We have other areas where the summers are so dry that there's need to have water conservation just so we have enough drinking water. But aside from some of these types of reasons, which are very important, as far as managing a project site, if we improve the soil quality, improve soil health, which really means improving soil functionality, we can reduce ongoing site maintenance costs and potential damage. as well as reduce plant loss. And we know we've seen this time and time again through soil management activities. It is important to understand also that healthy soils can moderate the effects of climate change. Healthy soils, organic matter, are nature's buffer. Okay, so common constraints to soil health, there are a variety of them, but really in our region, the most important or biggest problems we have when it comes to soil health is is soil compaction, which has a lot to do with the texture of the soil, certainly, which leads to poor aggregation, and then limited soil depth, soil volume. Okay, but other things do impact or stress soil health. But these are the main things really in the areas we typically operate. Now, one of the other big issues we have is along with soil health, we have less green space. Less green space, less soil health, which means more compaction, more hard surfaces. That means we have more runoff. Um, um, we have worse hydrology of the soils. Compaction is really, really bad when it affects soil hydrology. But where we are today, where we've done a lot of building, is a lot of the water that used to seep through the soil into the aquifer and also be then released through evapotranspiration through the trees and plants, most of that water now runs off. When water runs off, it carries contaminants with it to the rivers and surface waters, right? So that's one of the key aspects that we start talking about more recently about why do we replace and amend landscape soils. But more operationally for you all, well, we have projects that are operating or being created in soils that are damaged or depleted. Some of them are coarse, which don't hold water very well, which don't hold nutrients very well. Most of the soils we deal with are more fine textured, silt and clay, which means they're dense, um, they're easily compacted. So it's easy not to have good percolation or drainage or slow water absorption. And these are things that perpetuate the more water perches on top of the soil, the denser it becomes, the harder it is for the water to move through the surface. So this is a big, big problem. Compaction, low aggregation, low air capacity in soils. Also, of course, when you all look at a construction project, well, the contractors would have already been in and removed the top profiles of the soil, horizons, I should say, to get to a horizon which can be more easily compacted so you can build on it. Then hopefully they're bringing back a good soil back onto the site, but you guys don't know that, how good that soil is until you get there. Um, some sites, this is not done often where we actually hold the soils on site. I kind of wish we could do that more and more. Lots of times, if we save the soils, we don't properly protect them or manage them. We should be stripping soils based on horizons and stockpiling them in horizons and then protecting them so if rain hits them, they don't erode, certainly. And then on other aspects of the site, we have heavily compacted areas from equipment or vehicle traffic that really should be decompacted by the time you all take or start your function on the site. Sometimes we have pretty good soils that were on the soil or that were placed on the soil, and then there are bad soil practices after the fact, often by the contractor with big heavy equipment that compact the soil. And as you can see here to the right in the little graphic, you basically take the soil and you mush it and you compact it and you push the air pore space out of there. So you have small pore spaces, but you have no macro pore spaces, which are important for managing water. Um, and in many of these cases, it's really hard for roots to penetrate the compacted layer. And this is just a table I wanted to show you, not for studying, but it basically shows you that we have a pretty good understanding of what the big bulk densities of soils based on their texture are, um, what are most beneficial to plant growth. And if you look at these column 1, 2, and 3 here, and you look at the ideal bulk density, you don't have to compact the soil all that much to start restricting root growth. And that is a huge problem, especially again when we have less and less green space. Okay. And of course, the finer soils are much more easy to compact, and that definitely negatively impacts plant root growth. A different way to graphically look at this, if you look at the soil to the left, the natural soil, once you start compacting it and you push the air pore spaces, when you start looking, the bulk density goes up because you have more solid material, sand, silt, and clay mushed into the same volume of space, and that innately increases bulk density and reduces airspace, and the airspace which holds water. So the compaction, aside from the texture itself, can really impact the bulk density of the soil. And if you have high compaction, more compaction, that yields less air, and less water holding capacity. And remember, plant roots will actually require more energy to move through those finer pore spaces. So it actually takes more energy for a plant to establish, which is why plants have a harder time growing and establishing in poor soils. So if you have these dense soils, that causes it basically it physically impedes root growth. And again, as I mentioned earlier, it primarily is affected by the bulk density of the soil, the pore size, which is again affected by uh, um, uh, soil texture and structure, and as well as moisture content. The drier the soil is, the harder it is for the plant roots to get through it. And of course, it also affects the ability for plants to be aerated, to get for oxygen to get to roots, which they indeed need. So that's why it's really important to understand the soil you're going to be planting in. It's key that you test well in advance. It is important that the people that you're working for, if the contractors, the general contractors, have not done good soil testing, it is important for you all to do that yourself. It will impact the plants that you can best grow there. It is important too to work with a lab that you feel comfortable picking up the phone and calling and having them walk you through the test results, to help you understand what the findings really were. But good test results should also provide soil remedies, tell you what to do to improve the soil, and then that will again impact your plant selection. We test typically for physical and chemical properties of the soil. We don't really test for biological properties, though we are doing that more and more, though I'm not sure we have consensus on what all that data means. The one thing that we do know is the higher the microbial population, the more species. Um, Generally, that means we have healthier soils and we can grow more diverse plants. Okay. Um, what is soil? Soil is technically just the top layer of soil of the Earth's crust. It consists of sand, silt, and clay, varying amounts of organic matter, plant nutrients, water, living creatures. You sometimes see the term the soil food web, and this is research that's been done by a variety of researchers, and it really goes to basically the next level thinking of soil and understanding that the soil doesn't only have physical properties, but it actually has nutritional properties and other properties that fuel um, the animals and plants that grow within it. And this is a very interdependent web of different creatures, and it's fueled by carbon, by organic matter. It provides energy to a lot of these living creatures. Remember, soils are dynamic. They're always changing, but they change very, very slow. They talk about the creation of soil taking hundreds of years to 1,000 years, and it's impacted by a lot of things, um, but they are always changing. And when we take a poor soil with low organic matter and we put a bunch of organic matter in there, and basically and not wait for the hundreds of years for the organic matter to break down and stabilize and work its way into the soil, we are basically jump starting soil creation by doing that. And the science, of course, of soil creation is pedology. Soil has a lot of functions as far as plants go. It's a physical media for the plant roots, anchoring the plants to help the plants stand upright. Of course, I mentioned earlier, it houses microbes and animals and such. It also acts as a repository for plant nutrients, organic matter, and water. So it helps to sustain the plant um, and productivity all around. It regulates water flow through the environment. So good soil that can absorb water and slowly perk it by percolating water through healthy soils. That's nature's way of cleansing the soil and binding and degrading uh, uh, um, soil contaminants. And of course, organic matter works as this incredible buffer that affects air quality and water quality and can indeed impact global climate. The key aspect here should be in a lot of our projects is to make sure there's enough organic matter in the ground to reestablish or jumpstart the carbon cycle. And typically, we're talking about 4 to 5% organic matter by dry weight. Um, I just show you this because I went to horticulture school in the early 80s. We were seeing this beautiful graphic to the right saying this is what soil is. And of course, they were totally fibbing to us here because the ideal soil is 50% solid and 50% air and water. Um, but the true fact of the matter is, most of the sites we deal with have less than 1% organic matter, and they're so compacted that there's much more mineral component than there is air or water. And we talked about the impacts of that. So understanding soil texture, the soil triangle. I don't know if many of you were have nightmares about this from back in college, but it's this grid system that tells us, we test the soil for the content of sand, silt, and clay, and based on the volumes or the percentages, it places us in this triangle, and it allows us to talk about the type of soil to people from 5 states away, and we have a good understanding of what the general characteristics of that soil are. If you look over to the right really quick, you also will see that there's a magnification of sand right over here, where you can see this is somewhat cylindrical sand, but you can see it's rounded. There's a lot of pore space in there. If you try to compact it, it's hard to do so. Below it is a type of a clay, and we were always taught that clay was like bricks in the soil that can stack on each other. But if you see here, it's actually like sheets of paper, and you can see the dark lines here are actually air pore spaces, but they're very, very small. And look at this. This magnification is 19,000 times. So clay is very small. It can stack up on each other and not easily let water in. And then when it gets there, it does not let water easily out because it's bound. Um, so understanding that, and just by kind of getting a mental picture of sand and clay, it gives you a better idea of why Clay soils can get very, very dense and not accept water, right? Um, Organic matter, we look at organic matter a little bit differently the past 20, 25 years, ever since the USDA really got deeply back into studying sustainable agriculture. We now know that organic matter um, I want to say it's a moving target. It changes on an ongoing basis. So plant roots and microbes and insects, they're part of the living biomass in the soil, and there's a small amount of them, a smaller percentage. When it dies, it's considered to be active organic matter. And all that really means is that there are certain microbes that attack that and start using it for energy and breaking it down and start stabilizing it. And as they do that, they cycle nutrients back to the plants. They actually help with disease suppression. Um, and then when that organic matter is stabilized, so a lot of the cellulose is broken down and you have more lignin and hemicellulose, it becomes the organic matter becomes more passive and it changes much more slowly, more like peat, right, in the soil. And this is great for holding nutrients and for holding water. And what the goal here is, you get enough organic matter in this soil before you start the project, so the plants grow real well. The microbes and the bugs want to live in there because there's food and there's energy for them. And then you have enough passive organic matter over time that it helps living biomass continue to grow and flourish, and you keep the cycle going. That's the concept. When it comes to lawns, the denser you can keep the lawn and manage it well, the more you keep organic matter in the soil. When it comes to planting beds, after you incorporate the initial organic matter, keeping it well mulched will also keep and replenish organic matter. But you want to keep that carbon cycle going. And as we've learned about this more and more, we start throwing around the terms organic matter and humus and humic substances, and sometimes they're used interchangeably. And this slide here is really for your reference. But generally, when we use these terms, organic matter is this carbon-based material. They sometimes refer to it as humus as it gets older or more stabilized. And then a small fraction of this well-degraded organic matter are humic substances, like humic and fulvic acids. And we actually can test things like bloom and compost and other things for humic substances now for the first time. I think we've been doing it for about 10, 12 years now. We finally have an inexpensive test method. So we can actually test these materials for humic substances. So with that background in mind, what do we do once we get to the site? And we want to talk about assessing the site and preparing it for our landscape, obviously. So the first thing we hope to do, and the early part of this should be being done by the contractor, though the landscape architects will be brought into it. One of the first things they're going to do is they're going to get their eyes on the site. They're going to look for site features. They're going to look at topography. Are they keeping it the same? What's the existing soils look like? And in many cases, it's really important to go to the site to get your eyes on it, because there's certain things you sometimes learn outside the soil data and pictures and such that they send to you. Sometimes it has to do with the surrounding areas and vegetation and other environmental pressures. Okay. But the key aspect here is you may have great ideas on what you want to do to this site, but then once you do the site assessment and the soil evaluation, that actually may change your concept of your overall design and your plant selection. So, hopefully this is going to start off, the site assessment is going to start off with the contractor excavating soil pits throughout the site as necessary to understand how deep the soil levels are. They're going to then, of course, sample that soil, and they would strip it eventually to get to where they need for construction. But remember, lots of times during this process, they should be looking at percolation rates of the soil, so we understand a lot about the site, water over the overall hydrology of the site. And of course, in the same process, if we're keeping big trees, we mark them off and we protect them. Um, and it really is important for people to be who are closely involved in the project to be involved in this part of the process. Note that if you all want to go to a site and look at moisture percolation once they bring some soil back on the site per se, or even before that, this is a reference slide that walks you through the process of using a metal ring. Literally, we used to use coffee cans back in the day. And, our goal is to have over 1 inch of percolation per hour. Two is kind of ideal for high use soils. But anyway, this is for your own background knowledge. So we have this soil. You guys walk onto the site. Hopefully, this site demolition has been done. Construction's been done. The curbs are in, hopefully, and the coarse grading is done for the site, hopefully, right? If the soil is left on the site, typically what they would do is they would strip it in 6 to 12 inch lifts typically. Hopefully they're moving it by horizons. They're stockpiling it by horizon. So, the O horizon, which is the highly organic, that's the most important landscape based. So you want to make sure that's kept separately. And hopefully after the stockpiling, they respread it back onto the site, putting the soil down in the proper order. One of the things that we could do, we would have a lot more success on project sites for trees and for water management, is if we use more than 6 inches of finished landscape soil. Very controversial comment, but it's true. And then of course they're going to do some rough grading and final grading to the sites. And lots of times you guys are already on the site when this is happening, and sometimes you have already planted trees before the final grading is done. But to fix the soil itself and get ready for planting, obviously we're testing the soil throughout, and obviously, you need to go throughout the site and do some initial soil sampling throughout the site to see if there's much variance of the soil quality throughout the site. Very, very often you're going to be adding organic matter. You may be dealing with other physical improvement requirements of the soil, pH modification, whether through lime or sulfur. And then you're often going to address or adjust nutrients. And this is all going to be, these materials are going to be incorporated into the soil. Hopefully the early rooting depth of the soil, 6 to 12 inches deep, deeper if you can. We always have to say out loud that, you want to see these materials incorporated when the soil is not too wet, not too dry. And then after we get that grading done, we try not to over incorporate. And then we plant and we mulch wherever is necessary. Note that if you want to do a test on the site to see if it's ready for tillage, this is again another reference slide for you to take home later on. You can walk along the site, pick up some soil in your hand, squeeze it. If it holds together nice and tight, and you drop your arm down to about your waist height, and you drop the ball of soil. If it shatters, typically you're at the proper moisture content that it's okay to do your soil incorporation. Remember that the depth, the rooting depth of plants vary wildly, especially trees, of course, which tells you, how much good functional soil and subsoil you need on the site. Turf, we are almost always putting down 6 inches of soil. We do see people doing 4 inches which is problematic. We actually should be greater than 6 inches. Um, Newly planted trees need 3 foot of soil, not of topsoil, but of a combination of topsoil and decent subsoil. We do see, we are now placing um, pre-made blended soils in the foundations around buildings, and we're putting in thicker layers now, which is a great thing. We're actually looking at the plants and shrubs and things, and we're actually putting deeper layers of this of landscape soil, which is very, very beneficial. We can't forget that trees do have certain stressors like reflected heat and such around buildings that can stress them. So more better soil is better. I don't know if that was good English. And then, of course, there are lots of raised beds they're typically 12 inches minimum depth, up to 24, um, and then typically, best case scenario is we are decompacting the soil underneath that raised bed, so there's not a soil, a perched water table underneath the raised bed. A lot of times we fix the soils with soil amendments. Again, today we look at soil amendments not only improving the soils physically, but also biologically and chemically. Bloom, other recycled products like compost do all those things. And a lot of our landscape projects, we can either, we sometimes, well, we primarily used organic matter-based soil amendments for typical landscape applications. And it's for the higher tech applications like green roofs and bioretention, sometimes in ball fields, that we used mineral-based soil amendments like expanded shales and clay and things like that. These things are really, really good because they don't break down, but they're very expensive. And for that reason, and also they're heavy, so trucking them is very, very expensive. So we often, in most landscapes, we fix the soil using organic matter-based soil amendments. And organic matter-based soil amendments fix the soil, improve the soil physically, chemically, and biologically. As we mentioned before, one of the biggest benefits is the physical benefits. Again, improve soil aggregation, where small particles of soil here that I'm pointing to the right, um, as microbes break down the organic matter, they spit out these biologic glues, which stick particles together and clump them into crumbs or aggregates. And that allows more large pore spaces to form, almost like you have sand in the soil around them. That does a lot of good things for slowing down soil compaction. Another great benefit of adding organic matter to the soil, as you can see here. Also improved water holding capacity. Um, Great research has been done showing that by increasing organic matter in the soil, by each percent of soil organic matter we increase, we hold an extra 16 to 20,000 gallons of water on the site. So we sometimes talk about in landscape projects strive for 5% organic matter on sites. By doing that, we can totally modify the structure of the soil and really improve the hydrology of the soil in one fell swoop. When we do that, we also reduce irrigation requirements quite significantly. But here's a couple quick examples. I won't test you on this later. But as we add, in this case, it's bloom to the soil. Here's clay soils and sand soils. So you can see to the left, 100% clay soil, 0% bloom, 90% clay, 10% bloom, all by volume. Note that as you add more organic matter, whether it's clay or sandy soil, the water holding capacity of the soil increases with organic matter added, right? Um, but also, you also see the bulk density goes down in the soil. But also you see the hydraulic conductivity, the movement of water, the percolation rate of the soil increase um, with organic matter. Basically, again, this is the large pore function of the soil. Here's the Bloom Woody Blend product. We'll talk about that in a minute. Again, the more we add in dense soils or lighter soils, the more we add, the more we increase water holding capacity. And again, when it comes to hydraulic conductivity, the more we have, the better we perk water. And I know this is counterintuitive because in the engineering world of sand, that's counterintuitive. But it's because the organic matter and the microbes work together to create these large pore spaces. So the organic matter swells, holds water, um, it sits in the pore spaces and slows water movement. And it sits in these air pockets until there's enough water that hits it that gravity takes it out of the profile. Okay. These organic matter sources also provide slowly reducing nutrients. The biosolids based ones like Bloom provide more nutrients than a lot of the other ones do. A lot more slow release nitrogen and iron. And this has all been proven out by research. We know that taking these organic materials, adding them to the soils, that all of these things I just talked about here, they have been proved through research on Bloom for specifically at University of Maryland and Virginia Tech. Um, Organic matter also helps to improve the cation exchange capacity of the soil or the ability to hold nutrients. It feeds biology of the soil, but also brings biology into the site, into the soil. Remember, the biology in the soil cycles plants and plant nutrients and helps to stabilize and improve soil structure. Big deals for the long-term success of a landscaping project. And then remember, when we get enough carbon into the soil, we grow better plants, so we extract more CO2 from the air. We now know that trees, especially, exude stabilized carbon from their roots. So it's one of the greatest ways for us to slow climate change is to have highly vegetated areas, especially large trees that can exude organic matter deeply into the soil. Um, so the organic matter materials are varying, and in the Mid-Atlantic area, compost has been around forever. You know, when I first started, it was peat. We use so little peat anymore, much less sustainable product anyway. And so Bloom, for instance, is a newer type of soil amendment created through thermal hydrolysis at the DC water wastewater treatment plant. It works utilizing high pressure and temperature, so the material's weed and pathogen free, and it creates a highly organic matter rich material, rich in nutrients. Really cool research done by Virginia Tech showing that there are some interesting drought resistant capabilities of the material, and of course, it brings in um, beneficial soil microbes. And DC water or provides a series of Bloom products. Uh, the first one is Fresh Bloom, which is a material that's used primarily in land construction and used by farmers and soil blenders. The material is wetter, so it's not as easy to manipulate by hand. It's typically moved around and incorporated with heavy equipment. So this is the least expensive of the products, and it's used on large land projects. And you know, I was involved in this project where we actually were able to test the soil on a site, bring sand in, bring the Bloom in, and actually create a soil in situ instead of bringing manufactured soil on the site. And we were able to do this for about half the cost of of bringing soil in. Um, Bloom has been used. I also worked on this project. Has been used instead of compost in various um, projects. Take a look. This was done on the ball field. Look how green this turf is over here. And this is just a project where actually leaf compost was specified, and they couldn't get it. And we were able to get a change order and had great success using Bloom. And we could actually use less because Bloom has higher organic matter content. And I'll just put this in here really quick to show you this. If you've not seen this, the South Capitol Bridge project, this was a really cool project we worked on for, geez, I think it was 2-3 years, where again, we manufactured um, Bloom with sandy soil and the addition of sulfur into soils that met the landscape architect's specification for soil. We used it on slopes for turf. We used it in planting areas. Um, whoops. And we had fabulous, fabulous success on this project. Now, there are plenty of projects where you can't use the fresh Bloom. And for that reason, um, other blended products, which are easier to handle, physically handle for smaller projects by landscapers, for instance, that are manufactured both by DC Water and by companies who work with them in the surrounding states. The most popular of the two is Woody Blend, which was really designed to be a direct replacement for compost. It's a blend of the Bloom and bark, and this product has worked quite well in a variety of landscaping and turf applications. Even we have more and more golf courses using it um, for finer turf. Here's the Four Extremes golf course. Of course, the courses at St. Andrews, where we just had this magnificent the, establishment of turf, and you can see by the color of the turf, the iron, the deeper green color brought out by the iron content of the Bloom. And this is over about a 5-month period, which is quite quick and beautiful. A home lawn, the same thing, soil incorporated, and we've had great success again using it in landscape gardens and nursery beds. And again, we'll typically use it in an application rate similar to compost at a 1 to 2 inch application rate. And then, of course, there's Sandy Blend, which is Bloom, um, bark, and sand. And this was originally developed as a turf top dressing, but it's now being used more and more for incorporated into soil for establishing soil and also flower beds. But here's a good example where after we core aerified, we top dressed with a thin layer of the Sandy Blend and dragged it in and seeded and had wonderful results there. Here's where Sandy Blend was incorporated, a before and after with a really, really dense soil in Northern Virginia. And I think the important aspect here to me, one of the reasons I like working with this product and um, 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 and you know, with DC Water and Blue Drop and working with Bloom is um, they've actually invested and done a lot of field research and also university-based research. So the things we talk about aren't based on assumptions. We've actually seen these things, and we have the data to prove it. But summing everything up here, it is important to know that Bloom is just is another soil amendment product. It's a tool for improving soil health. It's a tool for landscapers and landscape architects. We understand now with the types of soils we're dealing with and with the changing climate, soil improvement is really necessary on just about every project. We need to get to that 4 to 5% organic matter content. Um, that a good source of these organic materials are the recycled products, uh, biosolids based like Bloom and compost materials. And of course, by improving soil health, we really, really can help the sustainability of landscapes, make long-term successful landscapes by creating healthy soils and soils that will react better, that are climate resilient, and can help slow climate change, actually. So I hope that was informative to you. Note that I've worked with DC Water and Blue Drop to create standard specifications for the use of these material. There's test data, there's literature, there's other there's project assistance we can provide. And again, if you're interested in CEUs, April will tell you how you can try to get the CEUs. And I appreciate your assistance or your interest. And again, I'll make sure that this final presentation is available for people if they want to review it again on their own. And thank you again. And I will stop sharing and be happy to take any questions.
Great. Thank you so much, Ron. It's been a quiet chat here, but we do have one question, which is if Bloom holds any certifications that have helped establish the different uses of the product. I think I can field that. We are a bio-based product, which is a USDA certification for essentially natural products that are not petroleum based, and that covers everything from detergents to containers and so forth. And I guess our biggest distinction is being what is called a Class A exceptional quality product, biosolids product. That is a designation given by the EPA, and only something like 11% of biosolids products receive that designation. And that just means we meet their highest standard for things like pathogens and heavy metals and so forth, which makes it approved for growing edibles and so forth. So
And then also, let's not forget the fact that your products are registered in all the surrounding states as soil amendments or fertilizers.
yes.
So they're doing all the right things.
Do we have any other questions?
Now,
I have a
come on now,
question.
it's not a Friday
Oh,
afternoon, all right?
I raised my hand. I don't know if you saw that or
oh,
not.
sure. Go ahead, James.
Hey, thank you. Thanks, Ron. A good presentation. I am located in Maryland, specifically Montgomery County. We do work in Prince George's County. As you may be aware, City of Rockville and some reviewers in Montgomery County under the park and planning regime require urban soil profile rebuilding per the, I guess, the urban forestry at department at Virginia Tech under Susan Day, or developed by Susan Day. Are these soils or are these products sort of compliant with that particular specification?
That's a good question. And I know the city of Arlington has, I don't know
Yeah.
if they just use what's Virginia Tech's um spec on that, but we have been working with them on that. There are a few hiccups just with some nuances, which we've run into a lot with specs where, sometimes our type of product wasn't necessarily um considered when developing those specs. And um so like EC, Ron, I don't know if you can talk a little about soluble salt, since that's something that was in the most recent research, but I think that might have been one of the pieces, because they were in the process of incorporating it, and then there were some minor um product um
Characteristics.
parameters,
Yeah.
I guess, that gave them pause. So we're kind of still working on that.
Well, I'd love to see the parameters for that. In theory, there shouldn't be any main issues if they're trying to to recreate or reestablish the soils. But that's done through a whole profile, and I would, it'd be interesting to see the spec so I could better understand it. I'd be happy to give you a more formal response to that working with April.
Yeah, I'll pop the link in the chat.
That would be great.
Let's see. Nicholas is asking if the product is registered as an organic soil amendment or fertilizer within these states or organizations. I know the regulations surrounding that designation are a bit clouded related to biosolids-based products. I mean that I don't know about like states or organizations beyond the main armory listed. I mean that's what allows a grower to certify as organic if they're using OMRI listed products. And unfortunately, we are not. They had, going back quite a long time, long before I started with this, but Ron, I'm sure knows more of the history of biosolids based products just kind of being a blanket no on that.
Yeah, but
Ron,
yeah,
do
you can't. No biosolids product can be considered quote unquote organic for organic listing or for used on organic farms. It's just there are certain things that are just basically we're given a no from day one. Yeah,
for
even though
something
they're
that's
full of
going to be sold as organic, because I know there was, we had a organic farm, 1 acre farm that, they used it to grow these beautiful sunflowers. It wasn't a crop that they were planning to have certified. But they were a little bit frustrated that they wanted to use it and couldn't for the other. So we have to pick our battles sometimes. Steve says, please discuss the benefits of using Bloom products for projects in the critical area.
What is the critical area? It sounds like a bad sci-fi movie. What do you mean by critical? What do you mean by? Do you mean in the
Steve, feel free to unmute yourself. I know you have worked with Ron in the past here on some things.
within the check.
Oh,
Okay.
okay.
Well, you can, but application rates would be limited based on nutrient addition. But yeah, you could use it for plant establishment.
All right, last call for questions or comments. As mentioned, I will be sending out the slides after this, and actually we'll get the recording also available. And there will be a quiz to complete if you are seeking a CEU for ASLA. And yeah, thank you again, everyone. Thank you, Ron. And do get in touch if you have any other questions. Have a great rest of your day.
Yep. Thanks, everybody.